Hi folks, welcome to review day 2. Today we're going to be reviewing our content from chapter 8. So remember that chapter 8 was all on graphing quadratics, right? And we had lots of different types of quadratics, which we'll get into in a minute. But the two key pieces of information in terms of vocabulary that I want you to take away is vertex and axis of symmetry. So remember you had your quadratic, your parabola, like something like that, right? So your vertex was always this point where it changes direction, right? So it was decreasing and then it starts increasing. Or it was increasing and then it starts decreasing if we had something that looked like that, right? So that's what your vertex is. Now, depending on the form of your quadratic, your vertex has different formulas, okay? And we'll get to those with each form. Your axis of symmetry, I'll draw in green, is always at the x value of your vertex, right? So the equation for it is always x equals the x value of your vertex. All right? And we usually draw this as a dotted line going through the vertex, and it's a vertical straight line. All right? And we call that the axis of symmetry because on either side of the axis of symmetry, your function should be mirrored, all right? So that'd be like taking a flat mirror and looking at the mirror image of something, right? So that's the axis of symmetry, allows us to identify where a mirror would be placed if we were looking at this in terms of like mirror images and things like that. All right, so quadratics we split up into 3 forms. We had standard form, vertex form, and intercept form. Standard form was the most basic and also probably the most complicated in terms of graphing. So you always have the option of making a t-chart, right? Where you choose different x values and different y values. However, it's usually easiest to utilize some of our graphing tricks. So remember that the x value of your vertex for standard form is always at negative b divided by 2a. All right, so I have an example written in this light blue color that y equals 2x squared minus 4x plus 2. All right, if we were to try and find the x value of your vertex with that, we'd say, okay, we have negative, and my b value is negative 4. Divided by 2 times my a value, which is 2. So I have negative times a negative, so that gives us a positive 4. And then we have 2 times 2, which is, again, positive 4. 4 divided by 4 is 1. So the x value of our vertex for this example would be 1. Now, what you'd have to do is go in and plug this 1 in for all of your x's. All right? And that's how you get the y value of your vertex. Now remember, your axis of symmetry is always at the x value of your vertex. So for standard form, our axis of symmetry is always at x equals negative b over 2a. In our example that we did, we'd say it's at x equals 1. Because negative b divided by 2a was 1. All right, and remember to graph in standard form, you had to graph your c, which was your y-intercept, right? You graphed your c value, and then, like, let's say, like, this was your axis of symmetry, and then you had to reflect the c value across the axis of symmetry, and then you also had, like, your vertex. So those were your 3 points. You had your c, which is your y-intercept, your vertex, which is negative b over 2a, and then plugging that back in. And then your extra point was the reflection of c over the axis of symmetry. All right, after we worked with standard form, we came to vertex form. Now, vertex form is really helpful because it gives us information in terms of the vertex. And h comma k is always your vertex. So here, in our example, so our general form is y equals a times x minus h quantity squared plus k. Right? And in our example, we have y equals 2 times x plus 4 quantity squared plus 2. So in this case, right, we have x minus, well, the only way to get a positive 4 here is if we have a negative 4 as our h. So that means our vertex is at negative 4, comma 2. And it's at positive 2 because, remember, k doesn't have any sign issues, okay? So our vertex for that would be at negative 4, comma 2. Our axis of symmetry, remember, is always at x equals h, all right? So our axis of symmetry in this case will be x equals negative 4. All right, now the easiest way to graph vertex form is you graph your vertex, right? And then you choose an x on one side and an x on the other side, see where they end up in terms of the y. And the nice part is if you chose an x that was the same distance, right, away from your vertex, then they're at the same height. So that was that shortcut. All right? So that's how you graph in vertex form. And remember, you don't have to remember all the details of this, all right? It's just mostly getting the basics. All right. So after vertex form, we had intercept form. Now, intercept form always tells us our two x-intercepts. So our generic form is y equals a times x minus p times x minus q. P and q are your x-intercepts, and you have to always remember, when working with them, to flip the sign. So in this case, right, I have a plus 1. I have to flip the sign, so I get negative 1. Here I have a negative 3. I flip the sign, so I get positive 3. So P is negative 1, and Q is positive 3. Now, to find the vertex, you always do P plus Q divided by 2. And then you plug that back in for x, right? So if we were to do that in this example, well, we have P is negative 1 and Q is 3. All right, so we have negative 1 plus 3 divided by 2. Well, we have negative 1 plus 3. Negative 1 plus 3 is 2. So we're left with 2 divided by 2. And 2 divided by 2 is just 1. All right? So that would be the x value of your vertex. You then have to go in and plug this 1 into your equation for your axis. All right? And that's how you'd find the y value of your vertex. And last but not least, we come to our axis of symmetry. All right, and that axis of symmetry is always at x equals p plus q over 2. And since p plus q over 2 is just 1, in our example, the axis of symmetry is at x equals 1. To graph in intercept form, you graph your p, your q, and then your vertex. All right, and this is not necessarily like perfect in terms of like the exact, like making sure this is exact. However, I do think that this is at least good enough to show you the basics from chapter 8. All right, I will let you know all of you are going to be taking advanced algebra at some point. And when you take advanced algebra, all of this stuff comes up again. Literally all of this stuff that I taught you or that your math teacher taught you, all of it comes up in the very beginning of advanced algebra. So make sure that, you at least have some understanding of this. You don't have to have it 100% down. That's okay. You'll come back to it in a year or two. All right, but that's all I got for you today. Hopefully you had a nice review day of chapter 8.